Hi friends, welcome back in this series of FMT. Today we have another lecture of FMT in which we will be discussing on ROC-AUC curve, right? And we will also see the ROC threshold management. But before starting on that, I would like to recall that what exactly the ROC-AUC is. So before that, I hope you remember in the last lecture as well, we discussed about the confusion matrix, right? Whereas confusion matrix is nothing but a 2 by 2 tabular structure that reflect the performance of the model in 4 blocks, we can say, which are actual positive, actual negative, true positive, false positive, and false negative, true negative, right? Which in which we get the accuracy, we get the recall, we get the specificity, and we get the precision. If I tell them in a single rhyme, so accuracy is nothing but how accurate the model is, right? Or we can say it tell the does the model classify the data points, first thing, and it clearly tells that does the model classify the data points. That means the lesser the false prediction, more the accuracy will be. Secondly, we have is the recall. We also called it as sensitivity, which is nothing but it tells that how many of the actual true data points are identified as true data points by the model, right? And whereas specificity is nothing but it tells that how many of the actual negative data points are identified as negative by the model, right? And finally, we have the precision. That means among the points identified as positive by the model, how many are really positive on that. So this way we have all these matrix, or we can say the confusion matrix performance. Now we come to know that what the ROC is. So ROC also stands for receiver operating characteristics, or we can say it a ROC curve, whereas it is nothing but a technique for visualizing the classifier performance, right? So basically it has a graph which will be showing in the lecture as well, like this, right? And the graph is nothing but it is between the true positive rate and false positive rates, right? Whereas true positive is nothing but that is true positive divided by total positive, and false positive rate is nothing but false positive divided by total negative, right? So ROC graph is like a trade-off between the benefits of true positive and the cost, we can say, whereas the cost is nothing but our false positive. So let's see the case study, like we'll get to know that how we can use the concept in the case study. So basically we import the pandas as PD because we have a well-known CSV file or data set, that is Pima Indian diabetes data set. So you can easily get it from Kaggle as well, but I'll be also providing the link in the description. We have used this data set many times, right, in our series. Now we have some columns name in our data set, like pregnant, glucose, BP, skin, insulin, BMI, category, age, label, right? All these, and we import this CSV. So header equals to 1, names equals to column name. Now we print the head to get the top 5 rows. So here in this way we will get the head, so you can clearly see the data, what kind of data that is being storing in the data set. Now we define x and y, obviously, to do the train test split. So we get the x, so x is we are getting as Pima of feature calls, right? So all the feature calls will be in our x. So feature calls are nothing but all these are our feature calls, and y we are taking as the label, right? So here you can see that. Now we split the x and y into training and test set. So obviously we'll be importing train test split from model selection, and we are doing train test split of x and y. For random state, we are passing an integer, that is 1. Now train a logistic regression model on the training set. So simply we are training this. So from sklearn.linear model, we import logistic regression. We store the logistic regression function into logreg, and now we try to fit the model into this logistic regression. So guys, here you can see that how nicely the Jupyter notebook is also being described step by step. So in this this way you will go through with your own case studies, right? Now make class prediction for the testing set. So what we'll do is we will do y prediction class equals to logreg dot predict x test, right? Now here the classification accuracy is nothing but that is the percentage of correct prediction, right? So now we calculate the accuracy. So we import the matrix to get the accuracy score. So we import from sklearn import matrix. Now we print the matrix dot accuracy score of y test over y prediction classes, right? Now we get the accuracy of 75%. Now if we talk about the confusion matrix, as I just described, the true positive, true negative, false positive and false negative parameters. Now that is the table that describes the performance of classification model, right? So here you can see that we are importing PLT to import the matplot.pyplot numpy for a numeric operation. Now we get the confusion matrix on y test and y prediction class into this CM variable. We do the plt dot classification, right? Plt dot image show, so that will help us to show the plot, right? Now what we'll do is we will get the class name, plot title, y label, x label, y mark. So once you will do this, so finally your plot will be shown. I think there is some problem with my Jupyter notebook, although the cell has been run, but if you will also run in your end, you will definitely get the plot dot show, right, which will be showing you the true negative, false positive, false negative and true positive. Please do it by your end. If you get any problem on that, please do let us know. We'll definitely get in touch with you. Now true positive, true negative, false positive, false negative, this is the parameter. Let's say in our case we got now matrix computed from a confusion matrix. So again the classification accuracy is nothing but overall how often is the classifier correct. So if we print the true positive plus true negative divided by float of true positive, true negative, false positive, false negative, so in this way we will secondly print the accuracy. So you can see that first we will get these confusion matrix individual parameter, then we get the matrix of score. So these are the nothing but all these value which will definitely be shown in the plotted graph. Now classification error is nothing but, so overall how often is the classifier correct, as also known as misclassification rate, right? So if we get it here again print, so this way we are doing it in another way. So false positive plus false negative divided by float of all these true positive, true negative, false positive, false negative. So if we print in that case, but we are doing here 1 minus this classification accuracy. So this way we will get the sensitivity, right? So here you can see that first we will right, so here you have seen that first we got the classification accuracy, then we got the classification error. Now now the same will get the sensitivity, which is nothing but when the actual value is positive, how often is the prediction correct. So how sensitive is the classifier to detecting positive instances, also known as true positive rate or recall. So here in that case we will get the sensitivity. Now if we could talk about specificity, when the actual value is negative, how often is the prediction correct. So that means how specific or selective is the classifier in predicting positive instances, right? So in this case we get it as 89%. Now the false positive rate, so it is nothing but when the actual value is negative, how often is the prediction correct. So if we try to get that, we will use this formula and we will get this rate that is 10%. Finally we have the precision, again that is describing when a positive value is predicted, how often is the prediction correct, right? So that means how precise is the classifier when predicting positive instances. So here we get it from this formula, that is 75%, but the same we do in our y test and y prediction class, we get it as 68%. Now adjusting the classification threshold, so this is what the ROC threshold management will be doing next. So first thing, we print the first 10 predicted class with default threshold of 0.5, right? So here we are doing logreg.predict x test. from 0 to 10, so array of all these, right? Now print the first 10 predicted probabilities of class membership. So how we get that? So predict dot probab, right? So x test of 0 to 10, right? And it will print for all. So this will print the first 10 predicted probabilities. Now print the first 10 predicted probabilities for class 1, and class 1 is nothing but our diabetic. So for logreg.predict probab, right, x test, so it will do for 0 to 10, right, and for first class, that is diabetic. So here you can see that we will get the first predicted probabilities for our diabetic cases. Now store the predicted probabilities for diabetic class for all records. So how will we get that? So y predict probabilities logred.predict probab, right, x test. So we are getting it for all records, right? So definitely you will if you print this y predict probability, you will get that. Now if we try to reduce the threshold from 0.5 to 0.3 to predict the diabetic class, this will make a model sensitive to diabetic class. Though so the same we will do, but this time for 0.3. And if you compare all these values, right, with 0.3 and with the 0.5, you will definitely get the difference. For example, if we print the first 10 predicted probabilities, so here you can see the probabilities and here you can see the probabilities, right? 1 0 0 0 0 0, and here you can see that 1 0.1.10011, right? All these. Now previous confusion matrix default threshold of 5, right? So this is for 5. If the threshold is 5, so this is the confusion matrix, and the sensitivity has increased, used to be 0.24. So here the sensitivity rate got increased slightly. Now the specificity has decreased as well, so used to be 0.91. so now print 80, right, slash float 80 plus 50, right? So here we will get this 61. Observation: default threshold of 0.5 is not sensitive to our diabetic class. Lowering the threshold increase the sensitivity to diabetic class. ROC curve and area under the curve, AUC. So wouldn't it be nice if so the question here is, wouldn't it be nice if we could see the sensitivity and specificity are affected by various threshold without actually changing the threshold? So answer is simply, we will plot the ROC curve here. So the same thing I have shown you above, but there we hadn't the plot shown clearly, but here you can see that the ROC curve, how it will look like. So this is the false positive rate, that is nothing but 1 minus specificity, and this is true positive rate, that is nothing but the sensitivity, and this is nothing but the ROC curve for diabetic classifier. So here you can see that the difference, right? Now ROC curve can help you to choose a threshold that balances sensitivity and specificity in a way that makes sense for your particular context. You can't actually see the threshold used to generate the curve on the ROC curve itself. Now define a function that accepts a threshold and print sensitivity and specificity. So we define evaluate threshold. So we do this in for loop. Print sensitivity TPR threshold is greater than threshold minus 1, and print specificity, which is nothing but 1 minus FPR of threshold. If it is greater than threshold, then minus 1. Now we evaluate the threshold on 0.5. So we simply pass this threshold value, so we get the sensitivity and specificity. If we do the same for 0.3, so we get the sensitivity and we get the specificity. So in this case the sensitivity is increased but the specificity is decreased. So AUC is the percentage of the ROC plot that is underneath the curve, right? So this is why the AUC has been added with the term ROC. So AUC is nothing but that is the percentage of ROC plot that is underneath the curve. Now there is a very important thing, that is first argument is true value, second argument is predicted value when we do the ROC-AUC score. So this is the true value and this is the predicted probability. So in this way we get here the 80% of the ROC-AUC accuracy. So basically AUC is useful as a single number summary of classifier performance. If you randomly choose one positive and one negative observation, AUC represent the likelihood that your classifier will assign a higher predicted probability to the positive observation. AUC is useful even when there is high class imbalance, unlike the classification accuracy, right? Now, if we do the calculate cross validated AUC, so from sklearn.model selection, we input cross value score. So cross value score, we get the log-reg xy CV equals to 10, scoring ROC AUC mean. ROC AUC dot mean. So this way it will print the mean values of ROC AUC, right? So what are the confusion matrix advantages? So basically it allows us to calculate a variety of matrix, first thing. Secondly, it is useful for multi-class problems, more than two response classes, right? ROC-AUC advantages, so does not require you to set a classification threshold, still useful when there is a high class imbalance. So yeah, this was all about this ROC-AUC and the ROC threshold management. Hope you will get to know about it, and you will definitely solve your own problem with this reference. So thanks for being with us. We'll get back to you very soon with another video. Thanks a lot. Have a good time.